A ball of mass m is loaded into a launcher with a spring constant k. The ball is pushed down until it is at a vertical position y is equal to 0, and the spring is compressed. A distance delta L is shown. The ball is then released from rest. Immediately after leaving the launcher, the x and y components of the ball's velocity are vx and vy respectively. The ball reaches a maximum height of y max and lands a horizontal distance delta x away from its initial position. Energy losses due to friction are negligible. Which of the following is a correct conservation of energy equation that compares the total mechanical energy of the ball spring earth system immediately before the ball is launched to the total mechanical energy of the ball spring earth system the moment the ball reaches its maximum height? Okay, so this is a lot of information, but we can start off with so what is this question asking? So we're comparing the initial momentum versus the final momentum. The initial momentum is immediately before the ball is launched, and when we're at that state, that means the spring is compressed, and also the ball is at rest. And the final moment, this is when the ball is at max, or we can say is just at y max, the maximum height. And what is the system? Well, the system is the ball plus the spring plus the earth. Again, friction is negligible. Because friction is negligible, that means that that is why we have conservation of energy. That's because there are no net external forces. That's why we can use that principle in the first place, right? So now let's try to find the initial energy before launch. So then E initial pre-launch. So what's happening physically? So at this point, the ball is at rest. So when the ball is at rest, that means that you have no kinetic energy, right? And then the spring is compressed by delta L, right? And you also know that the ball is at the vertical position y is equal to 0, right? So then we can write the energies that are initially present based off of all this stuff that we know. So then we know that the spring potential energy, that's going to be US is equal to 1/2 K delta L, angular momentum, squared. And then the gravitational energy is going to be UG is equal to mg times 0. So that's just going to be equal to 0. And then the kinetic energy is going to equal to 0. There's no kinetic energy. So the total initial energy, summing all of those, it's going to be E initial is equal to 1/2 K delta L squared, because that's plus 0 plus 0. Now we want to find the final energy, EF, at max height. And then what is happening physically at this point? So at this point, again, the ball is at the top of the trajectory. So that means that your Vy is going to equal to 0, because when it's at the top, that means that it's no longer vertically accelerating up. And I have a diagram here. So this is when it's crossing between going in the positive direction to going into a backwards direction. It's going down basically. So that's because we have this defined as our coordinate system, and we know that the horizontal velocity Vx is not going to be equal to 0, because it's still going in the projectile motion, so it's still going forward horizontally. So, and then we also know that the spring is no longer interacting with the ball, right? So now we can write the energies that are present at the maximum height. So we know that UG is going to be equal to mgy max, right? And we know that the kinetic energy, we know only the horizontal motion remains, because we know that Vy is equal to 0. So then we only have Vx, right? So when we're writing out our kinetic energy, we can just write it in terms of just the x component. So we have 1/2 mvx squared, right? And then our spring energy, US, is equal to 0. That's because the spring is no longer interacting with the ball. So that means that the spring is no longer compressed. Okay, so now that we have all that written out, we have our initial and we have our final energy all written out. Now what we can do is we can write the total final mechanical energy. So that means that the EF, so this is mechanical energy, EF, that's going to equal to 1/2 mvx squared plus mgy max for just this side. It's also our mechanical energy. And now that we have both of these, we have E initial and EF, now we can apply the conservation of mechanical energy that we were talking about earlier, right? So that's E initial is equal to EF. And we know this system is the ball, spring plus earth system. And there is no energy loss, so E initial is equal to EF. Now substituting in our values for both of them, we have 1/2 K delta L squared is equal to 1/2 mvx squared plus mgy max, right? So that was, this was this, and then this was just this, and yes, this, now we can see which answer does this match. This matches answer C. All right,